So here I am with the third part of the 32-bit processor designing. The third module is the instruction memory. So let's go back to the diagram again for the better understanding of the connections. So this is the diagram. So you can see it clearly that the PC that we already created and this adder. Now after this, now we are making the instruction memory module. So here the address input we are receiving from the PC and and its output is in instruction. So let's get back to the code. So we declare both output and input as wire because we are receiving uh, the address from the PC, and that is again in the physical wire form, and the instance of is not also uh, having a value stored. So for the instruction we also write like wire, and rag is for the memory. We define the rag, that is 31 is to 0, like we created that this is a width of the memory signal, and the memory is defined as 0 is to 31. Now we assign the instruction is equals to address plus 32 D1. So this is not the code that we are going to use in the future when we combine the all the modules together. This is for generating the schematic diagram for this particular module. So if you want to generate, we can use this, right? But our main code is, let me just comment down this particular thing. How gonna right? This is only for generating the schematic. Now, what is the actually actual code? So the actual code is this: assign inst any instruction is equals to memory, and then bracket address, and then 31 is to 2. Why 31 is to 2 here? Because when we see that we are giving output as 4, 8, and 12 in this format, like adding 4 bits, 4 bits, 4 bits. So a memory space is going to be waste. Like for PC, value is equals to 0, it will store in the memory 0. For PC memory array with the 0 index, right? When PC value is 4, then it will store into the memory index 4. So the 1, 2, 3 index memory is wasted. So to make use of that memory, we write it like that 31 is to 2, means we are minusing 2 bits from the end. Like for explaining, I will be going to use the chat GPT after explaining this test bench. Now let's see the test bench for this. So like what we did in the earlier module, we write it in the same way and created the instance. So now for the memory accessing, we have to make sure that we are accessing it using the instantiated module that we created, that is otherwise it will not be patched from the memory, or it will not be accessed, right? So for memory 0 we give this value and so on. Now address, we have to also give values to the address, that is 0, 4, 8, and 12 for every 10. nanosecond gap. So now let's come to the this part, why we write 2 here. So let's see the explanation of it. So like here, what I earlier explained, that if PC value is 0, then it will store in the memory array with index 0, and for the 4 and 8 and so on. Now this memory 1 and 2 between this 0 to 4 is wasted. This part of the array is wasted. Now for uh, saving this wastage of the memory array, what we did is writing 2 here. So what that means, that removes the last 2 bits. So if the PC value is 4, so binary will be this. So after remove the last bit, it will be 1. So it is giving the 1. So the PC 4 is now stored in the memory with index 1 and so on. Right. So this is the explanation. Now see the schematic diagram of it. And this is generated only when you write this code instead of this. But for the main code, we need this only. Right. And also you can generate the simulation for this. So this is all for this video. I hope you like the video explanation, and if not, then also do comment.